So yesterday we learned, or kind of went over one way to divide polynomial function, and that's with using long division. Now there's a second way to do it, and that's with synthetic division, and that's what we're going to be covering today, is synthetic division. Now the way that we do synthetic division is there's going to be a few kind of main steps involved with this. And one of the first kind of main steps is making sure all the numbers are there, that they are in standard form. So one is that they need to be in standard form. So when I look at both of these here, this one here, so the biggest exponent is 3, yes? So if the biggest exponent is 3, that means I also have to have a variable with an exponent of 2, a variable, and a number. So I have to have all of them. So I have my cubic, square, 1, number. So everything's there, yes? We have to have it. Just like with long division, we have to have all of them. M minus 3. Okay. We have everything that we need. Now we're going to start with the setup. In the setup, the first thing we have is what I call the cubby hole, a little shelf. We're going to have that and a line. So when we start long division, we're going to have a cubby hole and a shelf and a line. Okay. Any questions on this so far? Any questions on any of this so far? We've got this down. We've got our cubby hole and the line. Okay, now the first thing we're going to do is go over what number or what goes in here. Now what goes in here is we're going to take this, what we're dividing by, this m minus 3, and solve it for the value of m. So m minus 3 is equal to 0. So what would we do? We would add 3 to both sides. So the value of m is 3, yes? So we're good with finding that solving for m is 3, yes? What we do now is we take that 3, the value of it, and put it in here. We put 3 in the cubby hole, in that little box. So we put 3 in the cubby hole. We put it in that little box. Okay. Okay. Any questions on this so far? We good with this here? Okay. What we have next is what's going to go here. What goes along this here. And what we're going to do is we're going to put all the numbers in front of the what we're dividing, or kind of I need to go back over divisor dividend that are in here. We want the constant terms. We want the numbers. We do not want the variables. And I want them in order. So I go first is m cubed. Well, what's the number in front of m cubed? 1. What's the next number? Negative 13, because the next number is in front of m squared. The third number is, and the last number is, okay. Any questions on this so far? We good with this here? Yes? Okay. So we solved for the value of m to get the number that goes in the cubby hole. The numbers that go in across the top here are just straight from what we are dividing, our polynomial that we're dividing. Okay? Everybody still following along so far? Yes? Okay. Next step. You drop the first number straight down below the line. It's going to be our starting point. The first number has to come straight down. Long division, it's pretty much what we're doing for long division, just in a simpler form. Okay. I'm going to erase this for now. Any questions on any of this here so far? No? Our next step, what we're going to do is we're going to do 3 times 1. What is 3 times 1? And this 3 is going to go on the next number. We're going to multiply down and place it under the next number. Okay. So we good with this first step, getting 3 here? Yes? Now we add. Negative 13 plus 3 would be negative 10, yes? Now we do it again. 3 times. So 3 times negative 10 is, and I put it under the 24. Then what do you guess we do next? We add. Well, it would be subtraction, but really we're adding these two. 24 plus negative 30. Well, guess what we do next? We multiply it again. So, we're done. That's it. So, guys, we are finished with the dividing process of synthetic division. That's all you have to do. Okay. Now, we're going to get to the answer. Box the last number under the line. The number that we just boxed, so when we did long division, the number that was left over was what? The remainder, yes? Whatever we had left over, what wouldn't divide, correct? What we just boxed is the remainder. So if we use long division, the number that would be left over at the end would have been 0. Now what we do is the variables. Is we have m for this, yes? We're going to increase. So, well, the first one would be m to the 0. Well, anything to the 0 power is 1. We don't have 1. So this would be the number without a variable. Then we would have m and then m squared. We're increasing the power. So the first one doesn't have it. The one after the box doesn't have a variable. The one after it is m. The one after it is m squared. So that's our answer. Our answer is m squared minus well, the 0 is the remainder. So do we have a remainder for this here? No. If we had a remainder just like yesterday, we would have included it with plus, so this would be 0 over m minus 3. But 0 over anything is 0. We don't have to have it. Questions on this here? Now, is it possible to get a remainder for this here? Well, yes. Is it possible for long division to not have a remainder? Yes. Having a remainder? Yes. It just worked out that the ones we did yesterday didn't have a remainder, or did have a remainder every single time. So this here, because again, I just did one with long division showing this, but this here is nicer, yes? This is nice as long as what we're dividing by, this here, is linear. It only has a power of 1. We don't have a square on it. Okay, let's do another one. So what do I need to do to get set up? Well, I need my cubby hole. or my cubby, and a line. Yes? Well, let's figure out what goes in the cubby. I would do that by doing what? V plus 4 equals, solve it for 0, so V is -4. Questions on this here so far? Make sure we're taking the notes. So then what goes across the top are the numbers for this here. And it starts at 5, and we have all of the variables we need, yes? 5, 4. We don't have the third. Do we have the second? First, 20. So we could fill it in. So I could say 8 is our first one. 32 goes with v to the fourth. What goes with v to the third? 0. V squared would be 0. 5 and 20. Exactly. If there is not a term there, we fill it in with 0. We fill it in with 0. We need that spot. We need that place. What's the next part in our, now that we have everything in place? We drop the 8. What's next? We would do -4 times 8. This would be -32. We put it underneath the 32. And then we would add it. And we would get 0. Okay, no one grab a calculator, so see here. What is -4 times 0? 0. Zero is -4 times 0. A 0 is -4 times 0. Now what do we do? -4 times 5. Would be okay. Any questions on any of this here? Any question on anything we did with this here? So what do I do next? I box the 0. I box the 0 as a reminder to myself that that last number is the remainder. I box it as a reminder that number is the remainder. Because the number next to it is the number without a variable. And then we have m to the second, third, and m to the fourth. I didn't specifically say this on the first one, but if these numbers do not have a sign in front of them, we know the number is what? Positive. If there's not a sign, it is automatically positive. So when I rewrite this, well, we'll have 8m to the fourth. Then what? Because m to the third is 0, m squared is 0, m is going to be 0. So they canceled out. We could write them in and then simplify them down, because anything times 0 is 0. We don't have to write it. We get 8m to the fourth plus 5. And that's it. Questions on this here? Questions on any of this here? If what we're dividing by is not a quadratic or higher, use synthetic division. If it's not a quadratic or higher, use synthetic division. Okay? Any questions on this here? I'll explain it here in a little bit. All right, we ready for this next one? Yes? Yes, it will. Because one of the things we cannot have, and this, I've looked through most of the assignment for this here, the term, so what we're dividing by, so here it's 3x minus 1. This number here, I believe for the homework assignment attached to this will be 1 on every single one of them. There's a reason they do this. And it's because that has to be 1. If we're doing the division, synthetic division, that has to be 1. So I divide it by 3, which tells me I have x minus 1/3. That's not nice, right? I can't just divide that by 3. I have to divide everything by 3. Fractional form, yes. Because this is one of the downsides to synthetic division. We have to do this. Now with long division, we could have just put the 3x minus 1 in front and gone from there. Yes. So the first thing we need to do is we need to find out what goes in the cubby hole. So we take x minus 1/3, set it to equal to 0, and solve for x. So x is equal to 1/3. So what goes up in here is 1/3. Now what goes across the top, because we have x cubed, x squared, and x, so it would be 1, negative 4/3, negative 17/3. What's our first step? Drop the 1. And then we would multiply, which would be 1/3 times 1, which is 1. And we would add. What is negative 4/3 plus 1/3? It'd be negative 1. And then again, we would do 1/3 times negative 1, which is going to be negative 17/3 plus negative 1/3. It'd be negative. So 6. So it would be negative 18/3 divided, so, and that reduces to negative 6. One-third times negative 6. Well, 1/3 times negative 6 would be negative 6 thirds, which reduces to negative 2. So it's just negative 2. And if we add these together, we get what? It is possible. It is totally possible to get a lot of very, very ugly fractions, but this one here it didn't. And a lot of that I would consider and say almost it's the dark closet of math. There's a lot of stuff that we're not going to cover in cases we will not cover for long division, synthetic division, for solving, for fractions like these here, anything past here, that we're just not going to talk about. Now, if you go into more advanced and upper level classes, they might delve a little bit more into it. And there's some tips and strategies to solve them. But this is where, but we're not going to go too far into some of this. The pre-calculus did go a little bit further into this with having these ugly synthetic divisions where we had big old fractions all the way through. So we won't go that far. But this is if, I wanted to bring this up, if this number here was different than 1, then we've got to do this. We have to divide and do it this way here. Now, let's finish getting the answer. Because this 6 here would not have a variable. The -1 would be, so we'd have x squared minus x minus 6 would be our answer. Questions on this here? Questions on any of this here so far? Not if we're, because what this is doing is, what did this do? It took the degree of this here, which was 3, and reduced it to what? 2. It's only going to reduce the degree of the polynomial by whatever the degree of this here is. Well, the degree of this is 1, so it took 3 and reduced it by 1, which gave us 2. If you remember back to yesterday, we did some where we had a degree 3 and divided it by a degree 2 of quadratic. Well, 3 minus 2 gave us 1. So the only way that we would get something without a variable in it is if the degree of what we are, the divisor and dividend are the same. If they're the same, then it would reduce completely. Yes. Yes. Any questions on this here? We good with this here? Let's see here. Because I feel like y'all are pretty comfortable with this here, yes? Okay. We're going to come back to this here later. Here. Use synthetic division to evaluate this here when x is equal to -4. Now, at this point, if I told you to evaluate, really what we're saying is we're wanting you to plug that number in for x. So we would say 5 times -4 to the third minus -4 squared plus 13 times -4 plus 29. We can plug it in. What it works out is that if we use synthetic division, the remainder would be the same as if you plug -4 in. The value that comes out of the function, if I were to plug it in, so saying 5 times -4 to the third minus -4 squared plus 13 times -4 plus 29. The value of this here will be the same as the remainder.
I have a question. Have you already technically plugged in whatever blank for whatever
Yes.
variable is? So we've already
Yes. So, now this here, it says x is equal to -4, yes? Do I need to solve anything? No. If it tells me x is equal to a number, it just goes in the cubbyhole. If it tells me x plus 4 is a factor, or divide this by x minus 4, then we would have to solve. Here it already told me the value. Now what are the numbers going across the top? 5. Since we have 3, 2, 1 number, we're good. 5, since there's not a number written in front of x squared, it's just minus x squared, it would be negative 1, 13, and 29. What do we do next? So negative 4 times 5 would be negative 20. We would add and get then we do negative 4 times negative 21. Positive 84. And then we would add. And yes, we would get positive 97. And then we would do again negative 4 times 97, which would be negative 36. I want to say 388, but double check me on that. We agree with that? Okay, negative 388. And lastly, we would add. And if we add these two together, the 9 carry the 1, which would be 3. Would be negative 359. And normally that'd be our remainder, yes? Because if we were doing long division, that would be the remainder. But use synthetic division to evaluate this. But what it's telling me also is that f of negative 4 is equal to negative 359. So if we were to plug that into the calculator, this thing up here, if you actually type this into the calculator, you would get negative 359. That was what it would give you. It works out to be the exact same. Which one? Oh, this here? So this here, the 5, negative 21, and 97, well, this is our constant term, our term with x, and our term with x squared. So the polynomial, if we divide it, would be 5x squared minus 21x plus 97 plus negative 359, and it would be over x plus 4. It works out the remainder is the value of whatever we plug it in. So if you typed in this, let me get a highlighter, this right here, if you type this here into the calculator, it would be this value. Those would be the exact same. And that's actually going to be handy going forward, knowing this. You already look at another one of these. Yes? You can, but I want you to at least show the synthetic division. So we're going to show the synthetic to evaluate this. So the number that goes in the cubbyhole would be 5. It already solved it for us. We don't need to do anything. Our numbers going across the top would be 4, and we would drop the 4. We'd multiply first. 5 times 4 would be 20. We put it under the 10. And then we would. So negative 10, or not negative 10. It would be positive 10. 5 times 10 would give us 50. Add and get So f of 5 would be 29. I mean, our polynomial would be 4x plus 10 plus 21 over, and it'd be x minus 5.
So you take 17 or answer.
No, this would be the answer. Because it's not asking you to divide, it's asking you to, what is the value of this function if we plug 5 in? Because this would be the same as saying, I'm going to erase this. If we did 4 times 5 squared minus 10 times 5 minus 21. Well, 5 squared is 25. 5 times negative 10 would be negative 50 minus 21. Well, 4 times 25 is 100. Negative 50 minus 21 would not be 79. It would be 71. And 100 minus 79 would be positive 29. And what did we get with synthetic division? We got positive 29, yes? It will do the same thing. It will give you the same answer. Yeah. Questions on this here? This here's it's for this here. It's not it's not making it any difference. But for something like this here, this is a little bit simpler to find the value. Or when we talk about like this here, it's going to be simpler to use synthetic division to find out what the remainder is than trying to type every single one into the calculator. Questions on this here? Are we good with this here? Yes?